Sony CCD-TR505E from eBay. It's broken, and there's already an obvious problem. The cassette mechanism doesn't close, so usually you would expect the small ratchet or the small clip, the small hook to keep it shut, and then the small motor that you see down there on the right, this one, the tip of my finger. This is the motor driving the whole mechanism up and down over there, this down there. Let me zoom in a bit and then I can show you what I'm talking about. So that's the motor that I'm talking about down there. It's not going to focus properly, is it? Ah, there we go. So this is the small motor. This is what drives the cassette mechanism itself up and down, so the lid and the whole assembly is being driven by this motor. And I don't think that there's a problem with that motor, but maybe there is a problem with a leaked capacitor that's giving that's causing the microcontroller of the servo system to receive wrong signals. All overall, aside from the fact that the cassette mechanism is stuck open, the unit is in very good shape. It doesn't look like it has been dropped. It doesn't look like it got wet. And the first visual inspection actually looks very decent. It's in very good condition. There's no pieces of plastic broken off somewhere. The viewfinder is a color viewfinder, and this is very interesting. So even though this is a more budgety model, which doesn't have high 8 function but only video 8, they gave it the color viewfinder, and this is cutting edge technology from back in the 90s. I'm going to open the viewfinder so the viewfinder on the inside is visible. So this right there is a very low resolution but color LCD monitor. It's not looking too good through the lens of the viewfinder, so it's very grainy picture. You can actually see the individual pixels, but it's a color viewfinder. And like I said before, it's cutting edge technology. Back then, usually these viewfinders were just a picture tube, a very small picture tube, but with a good resolution, with black and white only. And then Sony apparently said, okay, let's, put an LCD into the camcorders and sell it for like a penny or two more. So I can actually show you how it looks like. Let's turn on the camera mode. And the power supply needs to be turned on as well. There we go. So you can barely see. There's a picture displayed. I'm going to remove the viewfinder again. And then you can see that there is indeed a picture. Let me zoom down on it. So that's how it looks like. It's not very bright. The contrast is also not that good. Let me show you around the workshop. Maybe I can show you something. So you can see what's being displayed. There we go. My tray of components and boards and stuff. But it's as good as I can get it into the camera. It looks decent. It looks okay through the lens of the camera, but maybe if I zoom down a bit more, it's really hard to get the grain of the picture that you see through the bare eye, through the viewfinder. It really looks not so nice. Is it possible to grab it like that, like to show it on the camera? Nah. Can't see it that well. I don't think it's going to work like this. Is it going to focus? Oh yeah, there we go. There, that's a bit more like you would see it with the human eye, or when you look through the viewfinder. That's very grainy and just not a nice picture. Let's see. I need to shield the light off. That's how it looks like. Yeah, it won't focus. But you get the idea. Oh, wait. There we go. There we go. Ha, that's very nice. That's how it looks like to the human eye. So all these lines across the picture, they're actually physically there. And these dots. And when I look through the lens, the viewfinder, I mean, yeah, it's a color picture, and it's okay, it's all right, but it's not a very good quality. But it's still a color viewfinder, and I love to see my image that I'm recording in color. So camera function works as far as viewfinder goes, but there's an alarm saying something's wrong with the tape mechanism, please eject, and when you press eject, nothing happens. So if you want to, follow me along while I'm troubleshooting the device. I'm going to pause momentarily because I need to switch off the TV behind me. And I also want to log in on my computer to check if I can find schematics for or manual for this device. But as I said before in the previous video, all these units are very serviceable. There's not a lot of screws that you need to remove, and you're in pretty quick inside these devices. Let's see how the condition on the inside looks like. Okay, let's continue. First things first. We can test the unit if the tape mechanism doesn't work, because we can't test playback like that, and you know, it's not that easy to diagnose the whole device without proper function of a vital part of the camera. I will start to disassemble the unit now. So let's see, what kind of bit do we need? PH0 should be the one that fits the best. Yeah, it's all right. It's close. It's not the right one, but it's very close. It's enough. Schematic has been downloaded already in the meantime. Well, let's disassemble the unit. By the way, I'm logging, or I'm keeping a log of all the units I bought and about the price, and I think I lost control. I can't resist when I see a unit up for 10 or 15 bucks for sale on eBay, or what you would call a Craigslist in the US, or you know, the flea markets and the second-hand shops, the thrift stores. It's just so nice to fix these devices. It's so rewarding. It's such a nice thing to do. And for me, they're also a collectible item for some reason. I don't know. They're just like, even though they do the same, they're like, they have their own personality. Not like I'm not like talking to them or something. They just have their own look, and the way they're built might be similar, but it's you know, every single device has their own quirks and that you come across, or you find similarities between other models and this model. And that's what I like about these cameras. I'm checking the pinch roller right now because it's well illuminated. The pinch roller doesn't seem to be too shiny. It looks like it's all right. And what I want to do now as well is I want to check if the tape guides became loose. Tape guides are necessary for, as the name suggests, guiding the tape across the drum, the head drum. This one, you can see the heads down there, the video heads, these tiny holes. That's where the video heads sit. And as you see, probably from up here, yeah, you can see it very well. It's actually angled, so the tape doesn't go straight over the head, the drum, or usually it's either the drum being oriented in a tilted position, and this drum is straight, so the tape guide the tape over the drum in an angle position, because the way this whole mechanism works, the way video is recorded to these tapes is helical scan, and it has a lot of advantages compared to linear tape recording. One of them being that you are able to record more content, more information onto a smaller portion of the tape, because you don't have like a straight recording, but if this is the tape, the lines actually go like this, and the tracks that are being recorded are in angular position, and the relative speed of the tape when it passes the head is also higher because the head rotates, right? It's similar to VHS and other systems that use helical scan. And all overall, it's used to get more out of the tape, right? The tape cartridge has limited space, and you want to have a very efficient usage of the tape. So back to the tape guides, now that we're talking about the helical scan mechanism, I want to see if they are very, very loose. And what I'm doing, I'm nudging them with I mean, it's normal that they move around like this because it's not in a loaded position. But what I want to make sure is that they don't move with very small effort. They are, you can turn them around, you can twist them. They're like on a screw, right? There's like a, how do you say that in English? Like a thread that they are sitting inside. And if they're there's a small screw on these pads down there, if they become loose, then the video guides are going out of alignment, and therefore it feels alright. This one is also very loose, but once it's fixed into position, it's no longer flopping around like that. So the tape guide, the tape mechanism itself looks okay. It's not bent or something. There's no residue down there. Let's see if we can focus on the capstan. The capstan is down there as well. The capstan motor, or pretty much the capstan shaft. We can see it down here. Come on, focus. It doesn't want to focus. It focused just a second ago. Okay, there we go. As you can see here, it's going out of focus again on this side. Behind. There we go. Behind there. There, that's the capstan motor. And the capstan the top part of the capstan where the pinch roller also kind of pushes against, and the tape is being pulled across the mechanism via the capstan. But let's continue with the disassembly of this unit. Let's remove the lens. This is an additional accessory. It's from a German manufacturer, Zero Haze UV9 390. It's against the, I think, a glare or something. It's supposed to improve the picture quality. I think that's worth, trying it out and giving it a try with and without the lens attached. Okay, so all of the screws are the same in these units, except for the ones that hold the tape cover in place, and you can't mistake them. They're like all the same length, and they also have different colored Loctite on them. Let me zoom down a bit. So these are the screws for the case, and these are the screws for the tape cover. They're significantly smaller in diameter. The color is different, the Loctite they used, and I think it's all down to being able to separate the screws from one another, so that you don't screw the wrong screw into the right hole or the right screw into the wrong hole. Thinking of Louis Rossmann again. Oh no, you long screwed the short hole. Had to laugh very, very hard about this when I heard it for the first time. What Sony also does is they add like these small arrows to the screw holes where you need to remove a screw in order to disassemble the unit. And I think can already start to remove the front portion. This is always a bit tricky, and I'm always scared because, let's see, there's a screw here. Need to push here and there as well. And then we should be able to slide it out. There we go. It looks very similar to another model that I recently worked on. What was it? What kind of model was that? I forgot. Carefully remove the flex print and the cable. There's one capacitor already over here, and yeah, it's one of these. They get gunked up pretty easily. They leak, like all of them do. Let's put this aside and continue to look at the audio board already exposed here. Oh yeah. Oh yeah. Not in a very good condition. Can already see that there's a lot of leaky action-y going on there. You see that? See how the pads, the solder doesn't look shiny anymore over here? Yeah, right there. That's a problem. That's a problem. They all started to leak. Some of them more than others. Let's continue to look through the unit. Let's continue to disassemble it. Next is this part. Let's see if it slides out as easy as the other part as well. It does. Nice. And this exposes the whole cassette mechanism, the whole cassette deck. And now we can already manually operate the motor and get it to, you know, close down the mechanism, the tape mechanism properly. So you just apply some voltage, and it's not just some voltage, but it's actually 5 volts. Just apply them to the motor, and I'm going to show you how it looks like. I'm going to show you how I'm doing it. So I'm using these probes. They're old and, you know, small wires attached, and I'm using a regulated power supply. I'm adjusting the power supply to exactly 5 volts right now, and I think I can remove the phone. No, I'm not going to remove the phone because the vision is, you know, the angle is perfect right now. But you gotta trust me what I'm doing. I can show that later. So I'm adjusting the power supply to 5 volts, and I'm adjusting the current, the maximum current, to just a few milliamps. Actually, the smallest it can do before it's locking down into a short circuit, because it's a too low setting. And then what I'm doing is I'm applying the voltage directly to the motor, and then the motor should run as far as it's necessary to close the tape mechanism. By the way, there's the driver for that motor is able to swap around the polarity. So since it's a DC motor, it will run into the opposite direction if you turn around the polarity. And I cannot remember in which direction this needs to run, but let's just try it out, right? So let's see, this was, I think it was, yeah, this is going to close it. So what I'm doing is I'm increasing the current and I'm letting this thing close. There we go. And you are supposed to remove the current, the voltage. You remove the supply when it's, you know, completely retracted. Now that we have a closed tape mechanism, I think what I'm going to do is I'm going to power it on again, because I want to see what it does when you hit eject. I'm going to zoom out again. And let's apply voltage, let's apply power through the power supply. Okay. It's on right now. Yeah, the device is on, as you can see through the viewfinder. Let's see what it does when we press eject. Let's look at it from the side so we have a very good picture, very good overview. Yeah, you saw that final movement when it was already opened. This is supposed to where is the actual there's a trap somewhere. There's like this tiny hook that's used to position the mechanism in a way so that it kind of you know, ratchets into place. So this upper part here is supposed to snap in place, and then it's it's triggering a small switch, and then the unit knows, all right, somebody put a tape in and close it, and I can now safely load the whole mechanism in place. And let's see if this works now. There we go. Let's do it again, but more in a more zoomed down way. So pay attention to the clogs moving down there and to the motor itself moving. So I'm gonna press eject. Saw that final movement down there into the opposite direction? That's what actually brought the tiny ratchet thingy that's in there into the right position. And the tape mechanism already works. So what I want to do next is I want to put in a cassette and see what it's doing. Is it recording properly? Is playback working? Is the tracking, the tape guides, are they misaligned? Is the tracking all right? And is it even detecting a tape? Okay. I'm going to use one of my test tapes, not this one, because this is the 120 minutes one. Where's my other test tape? Here we go. Let me have a whiff at the device now that it's already starting to stink. Yeah, it smells a bit strange, a bit like leak capacitors, but it's alright. This is my other test tape, 90 minutes capacity, but this has been seeing some abuse in the past already. Let's look at how it performs in this unit. You know what? Let's have a more detailed look at the tape when it gets loaded. Ejecting it. See how it's unwinding and kind of rewinding, and let's look at this again, but from this angle. Let's look at how the tape gets loaded in place. See how the tape gets aligned in an angled way, how it's not really straight across the drum, but it's entering the drum at an elevated position and it leaves the drum at a lower position. And this is what these tape guides are for. As you can see, they are positioned above and below the actual drum. What's also important to know is that when the tape enters, this is I think the top side of the picture, and this is the bottom side of the picture. I might get it wrong right now, but if there's a tracking issue and you have a problem either on one or the other side of the image on the screen, you can pretty much determine which of the tape guides is in a wrong position. And let's see how playback performs. I mean, now that it's open, it's more susceptible to distortion, but it should work if we go to playback mode. And if I zoom down on the viewfinder, you can have a look at the way the image looks when it's being played back. I'm hitting play now. It's not showing anything. It's probably because the tracking is causing some problems. It might also be that there's another problem with video processing part of the tape, but yeah, it doesn't look too promising right now. So there is another problem going on. It's blanking the tape, and if you hit pause, it doesn't work either. What we can do is we can do an edit search. Maybe it's not blanking the picture then when we go into camera mode. It should warn us that the tape can't be recorded to. Oh, now the image in the viewfinder is black and white, so there's a problem with this unit. There's a problem. It's in camera mode, and it's, you know, the image is distorted. It's a live image, but something is wrong for sure. Let's see what it does in edit search. That doesn't even work because it's probably this is because the tape is in record protection mode. Let's change this. I'm showing you how that works. The tape has this small slider, and it's if it's engaged, if it's blocking this hole here. Oh my god, it's so hard to do in the tape mechanism. So if it's engaged. What the hell, man? There we go. If it's engaged, this hole is no longer blocked, and if it's disengaged, it will push down on a switch that's inside the tape mechanism. So let's remove the protection for a second, because, you know, I'm not going to record to the tape, but still, let's zoom down on the viewfinder again and see if there's a change when we use the edit search function. There we go. Oh no, it doesn't work at all. It doesn't work at all. Let's look at how it looks like when it's playing back. So what I'm doing is I'm pressing play, and now we're going to have a look at the tape and if it's, you know, bending or something. There we go. It doesn't look too bad. I'm just slightly worried about the fact that you see it twitching a bit here and there. Let's see how it looks like close to the pinch roller and the capstan. It's very hard to see it down there. Yeah, it's very hard to see. Yeah, there's something wrong in the signal path. I don't think it's a mechanical problem, and yeah, well, let's troubleshoot the device, the unit. Let's get the tape out of the device and close the cassette mechanism again. And continue with the disassembly. Let me quickly engage the protection again on the tape. Nice, and then I can put it back into the case. And then we can continue. I can continue for you with the disassembly. This part of the viewfinder will put it aside as well. And then we can continue and have a look at the board and then fix it. Hopefully it's not eaten up too many traces, because running jumper wires, it's such an annoying job. I mean, it's very rewarding if it works. You feel like you've achieved something. But the whole process of fixing it, it's annoying. It's a lot of work. Okay, let's see. Does it just slide out like that? So we can already slide out this part of the DC-DC converter. And did I miss a screw? This one is already out. And actually it should come off just like so. Let's see. This will remain attached. Yep, there we go. There's a flex print connected to the lower side of the unit. Need to make sure that we're not damaging anything when handling it. I'm pressing against the wrong part of the tape mechanism, and this is where the flexible cable is connected to the actual main board. It's a socketed wire, a socketed board. I mean, sorry. And it's plugged into the main board, and it's very hard to get out sometimes. To wiggle it loose. There we go. And this is these strange edge thingy connectors. There's no pins, there's just like connectors on the edge and also here on the edge of the actual connector. And this is it next to the viewfinder. Viewfinder is attached here. Carefully wiggle it out, and that's it. That's the whole camera unit. As you can see, it's like I said before, it's very, very serviceable. Whoopsie, I bent this too far. I hope I didn't break something. No, it's all right. And this is coming apart very easily. These are connectors for some sockets, for some buttons. This is the connector for the display and also for the buttons over here. And then we have the record button with the slider. It's all in there. Separate microcontroller on here as well for storing the time and the date. I think this one is for. And then what is this? This is the D7564. I think this is an SRAM chip, but I'm not sure about it. Might want to look it up later. But next, let's look at the device and the condition of the capacitors. Man, this is similar to another unit I fixed earlier already. Was it the 303 model? I think it was the CCD-TR505E. This is very similar to that unit. This is a DC-DC converter. It's very important to point out that these wires are glued down to the edge of the board, and also they're fixed with this piece of Kapton tape. The problem is that glue, it hardens up over the time, and then it breaks loose from the cable and from the board, and these individual contacts in this wire, in this flex print cable here, are very, very, very easy to damage. You can rip them apart, they break off, they cause all sorts of weird errors, especially with the power delivered to the device. So this part is what you really don't want to bend too much when you fix it. And there's also a lot of this in these devices, and that's just tin, it's solder. Sometimes you need to remove this solder in order to remove a certain board or a certain shielding off of the board. And then to disassemble the unit itself, you need to pretty much just remove this screw. You can slide out the DC-DC converter after you remove the solder. You can see that as well. If you want to remove this shield, you have to remove this piece of solder blob. And then we have another screw over there, and I think another one. No, it's just this one. It's just one screw that holds this board in place. And then, of course, you need to remove this part. And that's what we're going to do first. We'll remove this DC-DC converter and also take care that it won't get bent too much when we check out the unit itself. We could take some measurements, by the way. We could use the oscilloscope to measure, but what I want to do first is I want to check for the damage that the capacitors did to the board, if there is damage that they did, and I guess there is. Okay, so as you see, this wiggles loose already, but we need to remove it. We need to heat it up for that. And that's the first thing. Oh, it's still sizzling because I cleaned it. Let's remove the residue. So, let's see. Can we actually zoom down on that you see a bit better what I'm doing? Oh yes, yes. So I'm heating it up. And I'm sliding it out. There we go. And as I said before, you don't want to bend this into this direction. You want to prevent it from bending at all. And what I'm doing to prevent this is I'll tape a piece of Kapton tape over here, so it won't flap around too much. So what I'm doing is I'm sticking this over here, just for the time being, right? Just for the time being. So this prevents it from getting bent too much, and it's already doing what I was telling you. You see that? This is what you want to prevent. You don't want it to move around too much. And I need to find a way to prevent it from doing it, because it's already bending in all directions now, and it sucks so much. It sucks so much. I don't want to do this. So next is I'm going to remove this screw to bend the board up so I can place the DC-DC converter board back to the board itself. Oh yeah, it zooms in onto the top of the screwdriver and to my rubber gloved hand, of course. Finger porn. Oh no, I said a bad word. Is YouTube going to punish me for that? Oh, okay. Bend it back towards the board, and then we can already see that there's a lot of damage. Sorry, a lot of leaky capacitors. Let me have a better look at them before I show them to you. How many of them are there? There's like 47. 47, 6, 4. I'm counting 4 on this board. And 1, 2, 3 over here. And another one beneath this part? I don't think so. By the way, these flex prints, the glue, for some reason, doesn't come loose, so they're not as easy to damage compared to the other ones. Then we have more caps over here on the electronic viewfinder board. So in order to check for the damage that the caps did on the DC-DC converter board, I need to remove the shield, and I need to be very careful with this part here. So DC-DC converter is first, and then I also want to remove the bad caps off of the audio board. But that's for later. Okay. What I'll do next is I'll warm this portion up, and let's see if I can wiggle it loose. The shielding, I mean. Does it work? Not that easy. I think I need to remove this. I'm going to do it one-handed. There we go. Okay. So it's soldered over here, over there. Okay. It's already starting to move. Nice. Very good. There it is. I see one capacitor. But the question is, did it leak onto a vital part of this board? Let's see. Did it leak through the board? I need to check it myself before I get it on the shot. Oh yeah, look at that. Look at that. Let me see if I can show this to you. Let's zoom into the board. Reposition it. Can you see this? Do you see that? This is electrolyte that's being spit out by the capacitor, and it's leaking through. It's leaking through the vias, and this is what eats up the traces also inside the board. You see that? That's what stinks. That's what makes it stinky. And you see that green stuff there? That's copper that's already began to disintegrate. This is copper oxide, the green stuff. And the fluid, it's actually fresh electrolyte. So these units, they all start to leak right now. Some of them are in a you know, not as in a good condition as this one. Depends on where you store them. And then there's another capacitor that actually leaked more than I want to see it, and it's this one. Let's zoom in on that one. You see this? How dark the pad is? It's also concerning. But I know from experience that there's not a lot of small vias or small, as you see here, these small vias and these small traces down there. It's a lot of power rails distributed over here and a lot of ground shielding. Okay. I think I need to remove the whole board because I want to check if, like this one, the VS, what is it? VS what? VS93P board. I want to remove it because I want to check if one of these capacitors also leaked through the board to the other side and ate up traces, or, you know, ate up any of the devices, the components on the other side. So I remove the audio board and also the screw. There we go. Okay. Audio board to be fixed later. Goes into the pile. And there's shielding going on. This is where the drum connects to the board, and it's shielded because it's very easy to, well, catch some interference as some external distortion, and it will cause these tiny, I don't know how you would call them, this distortion looks like tiny fishes scattered across the screen. Like when you had analog satellite reception in the EU, when you lived in Europe. I'm not sure about the US, but when you had analog satellite reception and the weather was bad, you would see these tiny fish-like noise thingies on the screen, and it looked like small fishes. We used to call them fishes as well. Like, we would say, oh well, the image has some fishes in it. Like the German version was actually a cute one of fishes. This is, by the way, what I'm trying to remove here is the motor that we drove manually. It's the load and unload motor. It won't come loose. Have to be very careful with this stuff. Don't want to rip anything apart or off or something. There we go. It's not easy to remove these sometimes. Okay. And then there's this connector down here. Connects to the capstan motor. Need to wiggle it out. This is actually, I think, called a board edge connector. Then there's the LA&C connection. I think the board can stay inside the unit, but we're going to have a look. What I'm doing here, I'm lifting this a bit up because there's these small notches that will hold the connector inside. There we go, okay. And then lift it out of the unit. Does it work? Oh no, there's one over here. It's the keypad. There we go. It's liberated. Very nice. Okay. This is the whole tape mechanism. So if you would want to replace it, this is what you would replace as an engineer, I think, back then. And we can also have a look. There's like this belt with teeth on there. It's not like a normal belt, but it is a timing belt. It's very important that it doesn't slip, which is why it has these teeth on there. I don't know the exact name in English. I need to look it up. But yeah, this is kind of that belt that also drives these spools. It's connected to the capstan via a mechanism. And it's called the timing belt. So, I want to look for obvious damage caused by the lead capacitors. And this is actually looking concerning. What is this? Do you see that? Do you see this black mark? That looks like the audio board caused some damage to this connector. And there is this signal across the whole unit, right? It's it's AFM recording, and it also has this, what is it called? It's not like a pilot signal, but the carrier frequency. It's also routed across the across the audio board that I have over here next to me, down there, focus. And look at this, the connector has actually gotten some electrolyte on it as well. This doesn't look too nice. We need to clean this. And also, if you look into the connector of the audio board, where does that come from? It's definitely leaky action going on here. I mean, it's maybe caused by one of these caps over here. But they don't look too bad, to be honest. Oh no, what is that? Oh, there, you see that? You see this? It leaked all over the place. I didn't see this. It was too dark. Oh, that's probably from this guy here. Yuck. A lot of work to do. So, okay. Let's look at obvious damage done by the capacitors on the VS93 board. And we have one over here. So we need to check. Oh yeah, I already see it. Look at this. You see this? I don't like to see this. It leaked through the board already. So we have some over here. Somewhere else. Let's see if there's somewhere else. More if there's somewhere else. We have one over here. Over there. It doesn't look like there's leaky action going on. Where else? Over here. No. And then there's a large 220 over there. It doesn't look like. It's only down here. Oh, yuck. And since that stuff's conducting, it's maybe the reason why the unit didn't close the tape mechanism properly anymore. Maybe this is the reason. I don't know for sure, but it could be. What is this? This is just some glue, is it? Over there? Yeah, it's just glue. Okay. It's most of the time it's the 47s that leak. So I will start by cleaning this off, and I want to look at... Let's zoom in. I want to look at the traces after cleaning it. So this is how you can see it. Is this good like that? Yes. I need to... I want to put it straight. It's going to be a bit shiny, but can't be helped. There we go. Let's suck that stuff up first. Very nice. Yuck. We might need to remove this IC as well because there's skunk underneath it. So luckily this is what seems to be one of the power rails. They're a bit more there's more copper there, so the copper doesn't get eaten up too fast. If it's like one of these small vias, they get eaten up very fast. These ones. There's like gunk beneath the chip as well. Yeah, okay. Maybe we need to remove the chip later. To clean it, I'll inject some isopropyl alcohol underneath the chip. There we go. Okay. I need to flatten it out a bit. I used pliers to flatten the tip here so that I can clean it properly. Okay. What about the connector? Let's look at the connector. Is it able to be cleaned off? It doesn't look too good. It seems to be in pretty bad shape. I hope this is going to be fixable. Hope we can clean it. Let me scratch a bit. Oh man, it's the first time seeing a connector in a bad condition and affected by a leaked capacitor. Okay, let's replace some capacitors. Let's replace them. Let's first start with the DC-DC converter board. So this one. And I think I'm going to twist it off with the tweezers. The pliers, I mean. Oh yeah, it's so easy to remove. Let's zoom down a bit so we can see what's going on the board. Look at how shiny it is and how gunked up already it is. Oh, look at this. Look at this. It's already coming loose. Ugh. Ugh, look at that. Ugh. Oh my god, it's so disgusting. But that's how it is. That's why it needs fixing. This needs to get cleaned off. Isopropyl alcohol and then rub it a bit. Just on the surface. That's all. More rubbing. More cleaning. There we go. By the way, I'm testing another unit, which started to act up in a very weird way. It's a CCD-TR505E, and it's now, I think, in the second hour of recording, and it still doesn't show any sign of fault. I took it with me to shoot some footage on an event. It was Konichi in Kassel. It's a Japanese culture, pop culture, anime, manga, festival stuff, convention. I shot a bit of footage, and well, exactly when I wanted to record, at least for me, an important section of the video of the shots that I wanted to make. It started to lose certain colors, like as if a channel was suddenly no longer available, like a color channel. Let's see. Come on. And then I only noticed it when the event was already over, and I used the video grabber to transfer the footage. And I was like, why and how did that happen? This is really strange. I have another unit with a similar fault, but it's permanent, and now I'm testing it all the time. I'm looking at it using the TV screen just to see if the error reoccurs and to see if I can get it fixed. Okay, and we need to clean the other side as well. We saw that just a few moments ago. Since I can't get it into the shot properly, I'm going to zoom out and be very, very careful not to bend it too much. Yeah, it's going to be alright. It's going to be alright, like this. Let it seep through the board. I mean, if you would do it like very, 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 very reliably, you would soak the area that has the leaked electrolyte on it in vinegar. But I'm not going to do that, because cleaning is enough like this. At least It looks like it's enough. So there was a 47 on here. Let me get the wick and place the 47 back. 47 by 16 volts. Back onto where it belongs. So I can already move on with fixing the remaining parts. Recapping them. Let's zoom in again so we can see what I'm doing. There we go. Okay. It doesn't need to be super clean, just enough so I can reattach the cap. Okay, 47, 16. Tweezers. New cap. Whoops. They're sticky again. They are sticky again. And then flux. Not too much. Place it on the board. Yep. Orientation and alignment is okay. Solder. There we go. It moved a bit out of position. It's nothing that's a problem. Oh no, this needs to go away. Okay. Come on. Oh, you don't see what I'm doing because my finger is in the way. Oh, it's so hard to do. I can't see shit. There we go. I just want to touch it up again and make sure it's evenly spread and it's looking alright. I'm not bad at soldering, I'm just bad at soldering when I can see it. Like when I can see what I'm doing. Which one is next? Let's see. This is supposed to be... I don't want to bend it too much. What am I doing? I'm going to fix it in place. I have an idea. Oh, I have an idea. I'm going to fix it in place using this. It's called a third hand. Oh, you can't see what I'm doing. Let's see. So you see what I'm doing. I'm using this very, very useful device to hold this thing in place. Like that. Oh, beautiful. Nice, nice. So I can work on the capacitors down here a bit better. And oh no, it's bending it already. Oh no. Oh, there's 100% going to be one of them. The connections that's going bad. Let me have a look at them. Yeah, for now it looks okay. I can glue it into place. Maybe this is a better solution. Let me glue it into place. I want to be very careful because this is causing me a lot of work when it breaks. I don't want to solder every single wire individually to that again. It's very fiddly. It's very fiddly. Okay. Okay. Even if it's fiddly, it should be alright. And then I'm going to reposition this thing and then clamp it into this again. So, okay. Yeah. We can work with that. I think we can work with that, yes. Oh man. zoom down, and then let's work on some capacitors again. This 47. I need to take notes. So we have 47, 4, 47, and 220 up there. Yes, okay. No, I don't need to take notes. I know what I'm doing. I can remember the values by heart. Let's add some flux first. Okay. Let's zoom in a bit more. This is going to be very hard for me. Okay. This is so annoying. Why can't they just create like some sort of alternative to remove this stupid DC-DC converter board? It's so annoying. I don't want to complain. No. I'm not going to complain. Stop it. Just stop it. Don't complain. It's still annoying. Okay. Okay, cap is gone. Clean it up. You know, if you're screaming at your monitor and if you want to tell me, you're doing it wrong, what are you doing? Let me know in the comments. I want to improve, and sometimes you can't improve without the help of any third-party people. So I don't say I'm not saying I'm perfect. Let me know if I'm doing something wrong. Let me know if you have tools that would improve my life. Fixing these cameras, removing the caps. Let me know. It's not like I'd be angry if somebody shared their knowledge. Okay. Let's use one of the 47s. 47 6 volts, smaller one. This is actually just, you know, these units is just replacing capacitors. Not very hard in terms of diagnosing the units if you just replace some caps. It's a very easy fix, and replacing these caps is, if you like manual work, if you like that kind of work, it's fun. Diagnosing a unit further is what actually takes the skill of somebody who understands how these things work, right? And for me that counts partially. I'm not an expert in analog video cameras or something. It's all self-taught. I'm too young to have worked on these units when they were in production, in daily use by the people out there. It's all self-taught. It's all just because I'm interested in that stuff. And if I do something wrong, like I said before, if you're an expert, let me know if I'm doing something wrong. Oh, this one leaked a bit more. It stinks. Disgusting. Oops. There we go. Here it is. Yeah, that sizzling sound when there's electrolyte burning away. It cooks away. So the reason I'm kind of retouching the pads with fresh solder is because I want to make sure there's no residue left. The stuff's burning up, right? It's evaporating. It's slightly out of shot. Oh, come on. Okay, next, let's remove the excess solder. Oh no. You shouldn't do this, by the way, what I'm doing right now, pulling, what I mean is pulling the wick across the pad and even ripping on the pad. Like, you should prevent this when you're working on the smaller pads or of ICs or like very fine pads, because then you will rip them out, you'll cause damage to the board. You will. It's very dangerous to damage the board like that. Very easy, I mean. Okay, this one was a 47 as well, 47 6 volts, yep. No, come on. I think I need another cup of coffee. I want another cup of coffee. What time is it? Let's see. Oh, it's 5:30 in the afternoon. It's time for a coffee. I want another cup of coffee. So I'm going to pause momentarily in a second after I place the cap. No, sorry, I soldered down the cap on the board. Damn soldering tip again. Why are they always getting weak or dirty or something? In this case it was my fault, it didn't heat up too fast. Excess solder, more flux, just a tiny bit. Oh, okay, that's fine. Yep. Okay, time for a coffee. Okay, I had my coffee break and I think we can now continue to replace the remaining capacitors on the VS93P board. The 247 microfarad capacitors were already replaced, and next is this 47 and this 220. I'm going to pause momentarily because I need to answer to a question that I just received over text message, so it's going to be cut out probably. Just 1 second. Continuing with replacing the next cap, and it's going to be the 47.4 volts. And I'm very curious if the problem with the video playback and also with the, yeah, pretty much the whole video section that we observed is going to be fixed after replacing the caps. I know that one of them is, I think, a filter capacitor or something. I think that it's a 220 that's playing a very important role in the video processing circuits. We'll see. Okay. We need to center it a bit more. Like that. Very nice. It's not too gunky and not too bad. Hold on, where's my syringe? There we go. I think a new Q-tip is going to be a good idea. Let's remove the excess solder on the board by wicking it away. Okay. I think I want to take a look at the vias. I'm going to scratch them a bit just to see if there's damage. Maybe there's, you know, some of the electrolyte that has been leaked beneath here, and usually when the silk screen comes off too easy, and then this is something where it's maybe interesting to check out if the via has been damaged. But it doesn't look like it's the case here. What about this one? No, it's one of them that are not terminated in the top or bottom layer. These boards have 4 layers, and only the top and the bottom layer are shown in the schematic. This is actually not really nice if you have via that vanishes into nowhere and you're like, okay, but where does it go? So you have to trace it manually. It's a bit annoying, but can't be prevented. You really need to go the extra mile in this case and see if you can fix it without the proper schematics, the board schematic. Okay, next, let's place the cap over there. I think I'm going to try to change the position of the light to overhead. Does it work? It makes it shiny, but it's not easy. It's not easy. Maybe this is better. Is this actually better? Is it? Yeah, let's do it like that. It looks better this way. Over to the next, which is the 220. Let's first zoom out again and position the bad caps over here. And then this one needs to go into the middle of the screen, or rather the picture, so it's being recorded in the way that you can see it properly. Okay. It's the slightly less convenient angle for me position, but we're going to get it done. It's going to be fine. Oops. Okay. What I really need to be careful is the neighboring components. It wouldn't be the first time where I'm like, okay, destroying one of the connectors like this one, or I don't know, suddenly a small resistor is stuck on my soldering iron. Yeah, things like these happen, so you need to be careful, especially in the crammy areas of these boards. There is a lot of other components. This one leaked as well. Meh. It's also pretty dirty. Yeah, it is. The pads look all right. The pads seem to be fine. Let's remove it with the last bit of wick. Let's see if it still has enough capacity to suck it all up. I think this one is full now. Okay, let's discard it. Let's discard it. Clean. Clean the board. Oh yeah. Looks shiny and fresh. Let's wait for the isopropyl alcohol to evaporate, and then add some flux. And dry the board as well manually, but it's already dry. Okay, let's add some flux over there and over there. And then add the capacitor, a new capacitor. Can it be that hard? Come on, behave. Is it just me, or is it a bit crooked? Let's see. Yeah, it's a bit crooked, but it's okay. I think this board is done. I mean, repaired, fixed. The caps have all been replaced. I hope it's not done. That would be very sad. 4 capacitors on this board. Next is this board, and I think we have less trouble with the DC-DC converter being converter being in the way. Let's liberate it from the grab of this crocodile clamp. I think I'm going to remove the lens assembly before continuing. Yeah, I think it's easier with that board then. There's 2 screws that hold it in place. By the way, I now know, because I checked it, I now know which unit this one is very similar to. It's indeed the CCD-TR505. Or was it the 303? I think it was the 305. Let me quickly check that. Yeah, it's the 305 it's very similar to. The 303 is another model. But the 305 is very similar to the 505. Probably it's just a color viewfinder. Because I don't see any difference in the way it works. It's the same cassette mechanism. Let's zoom out a bit. It's the same cassette mechanism. It looks like it's of course not having high 8 function. The zoom and all that stuff, it's all the same. And oh, look at that. Yuck. Ew. Leaky. Okay. Okay, let's see. This one is the 47. That looks pretty bad. The other side. Look at how dark this pad became. Let's try to remove it from the board. Let's add some flux and let's hope that it's possible to remove it by pretty much desoldering it, because if it's too gunked up, yeah, if there's too much damage already done, and also if it has been eaten away, it's a bit harder to remove it. Let's see if it works. Oh, the sizzling sound. But it looks okay. Looks like it's easy to remove. Oh god, it stinks. This one leaked pretty bad. It leaked a lot. I mean, there's flux on there now. But still, look at this. Look at all this gunk over there. Ah, disgusting. I think I'm going to add some more flux over here. And then I'm going to scrape a bit with some more solder. And I need more wick, I think. Oh, there's another piece. I can use this one. Nice. I can use this piece, which is still having a bit of capacity. Oh, did I now wipe away a resistor? But I don't think so. This one, I didn't pay attention. Oh no. I need to check. I need to check this. Oh no. Sticky. And the resistor, there was no resistor before. I think I checked it. I think I saw it in the video thumbnail, but I'm going to check it again. Why is it so sticky? What's going on? Let's remove this and see why it's being. Oh, no, okay, it was just the edge of the board, I think. Okay. No, come on. I'm going to check the video again because I really want to make sure there was no capacitor. But no, there wasn't. I think this is like a test point. But still, I'm going to check it again. No, they didn't place a cap on there for this board. I think it's a placeholder. Like they have some more circuitry over here. This looks like it could be diodes or transistors or something. And this looks like it's some kind of additional stuff going on here. It's just not equipped on this board, on this version. Okay, so we had a 47 microfarad capacitor on there. And I think I'm going to place... Where was it? Where did I put it? What's... Oh man, I'm a bit distracted just now. Where is it? Was it this one? Yeah, it was this one. And it's a 47 or 6 volts. I don't have that many left, so I'm going to use the 16 volts. Physical dimensions are matching. So it's not going to cause me any problems. Good. Next, the neighboring one, the 22. Okay. Most number of caps on one board is indeed on the audio board. It's 6, 8, 10, 11. Yeah, okay. But it's alright. Slowly working our way through the boards. This is leaking black stuff all over the place. All gunked up. Let's clean it. Okay. I forgot to wake the pads. Not a problem. Okay, this was a 22, and I think I have 2 different sizes of them, and there should be enough space to install one of the larger ones. Let's first see if it's fitting physically. I don't want it to be too tight. Yeah, it's fitting just fine. It's the same size. Same physical size at least. And the last one. And to reach the last one, well, what I need to do is I need to remove the shielding. This shield. And I think it was easy with this model. I was just... Was it even soldered down? I think with the 305 it wasn't. I'm not entirely sure. I first need to remove the top part, but this was actually soldered down. Oh, yep, here, over here, it's soldered down. Let's try to remove the shield. Okay, well, that was easy. Is it liberated yet? There it is. There we go. Okay. Let's remove these clips. It's easy to remove. Perfect. And also check if there's substantial damage that has been done by the leaky cap over here, but I don't think it leaked through. It's under this chip where there's probably damage, and there's also one more part that needs to be unsoldered over here. I'm gonna try to remove it. Like so. Okay. Alright, first I have to remove this side. It's clipped into place over here. What else? Where else? Come on. Is it actually soldered down anywhere? I can see it. Let me check something. So there is just one where it's soldered down and the rest is clipped into place. I think it's just a bit hard to bend them, but oh, there we go. Okay, this one is loose, and then this side. Ah, there we go. There's another one. So it's two sides actually. I did not remember this, but apparently it is. It is there. Okay. Yeah, before I burn my fingers, I need to wick this away, even though it's a lot of solder, but it should be doable. There's also so many components close to where it's soldered in place. No! Come on. I remember the last time it was this filly as well. Ah, come on. There's another one. How could I forget this? Let me wait a second and heat the desoldering gun up. Pausing for a second. Alright, the desoldering gun is heated up. I need to untangle the wire. Oof. So let's desolder this. I don't want to waste all my wick. Come on. Okay. Should be all right now. There we go. There we go. It's coming off. Oh yeah, it's coming off. There's no thermal paste. What is this? What is that? What is this in that capacitor? What is this? What is this? Huh? What is that? Whoops, it's gone. What is it? What is this? Where does it go? Huh? What? Did it come out of the capacitor? Where did it go? It kind of flew away. Very strange. Anyway, let's remove the cap and continue with fixing the board. Not too much flux. Oh, there goes the resistor. That's what I wanted to prevent. I hate this so much. But yeah, it happens. Whoops. Okay. Oh, man. So, that's the cap. It's all so very, very disgusting and crusty. Oh yeah, very crusty indeed. New Q-tip. This one is dirty. Let's cut a new piece of wick. I need to order a new one. This one is close to the end of the spool. Where is there we go. That's the pliers. Uh-oh, video is out of focus. Oh no. Zooming down again. so you can see what I'm doing. Good. Okay, one last step, cleaning the pad, and then we're done with this board after placing the cap back onto the board. Okay. Flux. I'll first let it dry, maybe. Good idea to let it dry. Another 47. It's sticky again. Oh no. Come on. Here we go. Okay. Now, some cleaning is required. This actually applies to all the boards, but I'll first start with this board, just so the remaining flux is being cleaned off of the board and any possible residue of the leak caps as well. Okay, let's clean this as well. I don't have any more. I don't have any more clean Q-tips. Need to grab some more. I'm going to use the brush. And then we also need to take care of the connector. That's also still pretty gunked up. But I need to look at it under the magnifying glasses, because it's not easy for me to tell if this is fixable or not. I'm going to look at it right now. Give me a second. Yeah, it does need some rework, but I think I have to do that off camera. It's going to be pretty hard to clean this on camera. Let me figure something out.